warahmatullahi wabarakatuh. My name is Nuri Hidayah binti Muhammad Rizwan. I'm from group PAS 0071C2. Today, I would like to present chapter 6, which is Aqueous solution. What is a solution? A homogeneous mixture of two or more substances in relative amount that can be varied continuously up to what is called the limit of solubility. Two components of solution. We have two, which is solute and solvent. Solute, a substance that can be dissolved into a solution by a solvent. For example, lemon, oxygen, and nitrogen. Solvent, a substance that dissolves a solute, resulting in a solution. For example, water, ethanol, and petroleum. Dissolution. Dissolution is a process by which a solute dissolves into a solvent and forms a solution. Concentration and molarity formula. Molarity, mole of solute, divided by volume of solution in liter. Concentration, mass, divided by volume. Relationship between mass of solute, number of mole, concentration, and molarity. Concentration, gram per dm3, molarity, mole per dm3, multiply molar mass of solute, gram per mole. Standard solution. Standard solution is a solution containing and currently no concentration. Standard solutions are generally prepared by dissolving a solute of known mass into a solvent to precise volume, or by diluting a solution of known concentration with more solvent. Dilution. The process of decreasing the concentration of a solute in a solution, usually simply by mixing with more solvent, like adding more water to the solution. To dilute a solution means to add more solvent without the addition of more solute. Dilution formula is N1 V1 M2 V2. M1 concept of acid-base neutralization. Definition. An Arrhenius acid is a substance that dissolves in water to form hydrogen ion H+. An Arrhenius base is a compound that increases the OH- ion concentration in aqueous solution. Bronsted-Lowry as a proton donor, Bronsted-Lowry as a proton acceptor, Lewis an electron pair acceptor, Lewis an electron pair donor. Physical properties. Have properties of acid and base. Acid tastes sour and base tastes bitter. And then for acid turn litmus red, for base turn litmus blue. For acid reach with base to form salt and water, for base reach with acid to form salt and water. For acid is electrolyte and for base is electrolyte with the same again. And for acid is rich with metal to form hydrogen gas, and for base is feel slippery. Here is example of common acid and base in the home. For acid, which is lemon juice, battery acid or soda. For base, baking soda, ammonia, soap. And then we have strong and weak acid. For strong acid is an acid that is completely dissociate of in an aqueous solution. For weak acid, the acid that do not completely dissociate into their con- constituent ion when dissolved in solution. Strong acid, a single-headed arrow pointing toward the ion's product is used in the equation. For weak acid, a double-headed arrow is used in the equation. This is example of strong and weak acid. For strong acid is hydrobromic acid HBr, hydrochloric acid HCl, nitric acid HNO3. For weak acid, acetic acid CH3COOH, carbonic acid H2CO3, formic acid CHOOH. For strong and weak acid, strong base, a compound that has an ability to remove a proton from a very weak acid. A single-headed arrow pointing toward the ion's product is used in the equation. Na weak base, as basic substances that do not completely dissociate into their constituent ion will dissolve in solution. A double-headed arrow is used in the equation. This is example for strong and weak base. Strong base is barium hydroxide BaOH2, calcium hydroxide CaOH2 base, ammonia NH3, sodium bicarbonate NaHCO3. And then strong base versus weak acid base. Strong acid, pH of strong acid solution is very low, closer to 1. For example, HCl, H2CO4, HBr. For weak acid, pH of weak acid solution is about 5 to 6. For example, ethanol acid, CH3COOH. For strong base, indicate by a pH value closer to 40. For example, NaOH, KOH, BaOH2. Weak base, indicate by a pH value greater than 7 but lower than 14. For example, ammonia NH3. That's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Nur Idina Natasha binti Muha, code program PAS0071C1. I will continue in this chapter. In this chapter, we should know about the pH. The pH scale is a measure of how acidic and basic a solution is. pH scale have a 3 part, which is acid solution, neutral and base solution. Volume less than 7, which is red, is acid solution. However, 7 is green, neutral and nature. And if a volume above than 7 is a base solution. Here have a picture in beside that. Here have an example how to calculate the pH. Here have a monoprotic or monobasic acid. Acid can be described as a monoprotic, diprotic, or triprotic. Monoprotic is hydrochloric acid, diprotic is sulfuric acid, triprotic have a boric acid. Here have an example how to calculate pH on the equation. Next, we have a monoprotic or monobasic base. Monoprotic base, we have a sodium hydroxide. Diprotic base, we have a sodium carbonate. And triprotic base, we have a sodium phosphate. Next, we have an example how to calculate pOH and pH. Step first, we need to calculate pOH, and second step, we need to calculate the pH. Value of pH is 14. Next, we learn about acid-base neutralization between strong acid and strong base only. Next, have a concept of acid-base titration, a method of quantitative analysis for determining the concentration of an acid and base by exactly neutralizing it with a standard solution of base or acid having no concentration. The appropriate indicator will be added to the conical flux to determine the endpoint, indicated by a color change. Next, have a titration requirement. The reaction should be complete and irreversible, rapid, endpoint can be easily detected, can be represented by a chemical equation. Here, how could be experiment titration? Next, have a acid-base titration. Titration is a common laboratory technique for determining the concentration of a solute. Most commonly, this is an acid-base reaction using solution with unknown and standard concentration. An indicator is added to signal the equivalence point when H plus equal to OH minus. In this picture, we can see how the color is changing. Titration curve. pH of the solution versus volume of titrate added. Titrate is usually a strong standard acid or a strong base. Equivalence point is the point of stoichiometric equivalence between the analyte and the reagent. Endpoint, a point when the reaction is judged to be complete by changes in color of the solution. Next, acid-base indicator. Chemical used to determine whether an aqueous solution is acidic, neutral, and alkaline. Here have a picture pH indicator colors. Here have a graph of titration. On the left have a graph a strong base titrate of a strong acid. On the right have a strong acid titrate of the strong base. This is a familiar basic concept. This is an example how to calculate basic concept.